meetup, Clojure meetup in Palo Alto. I'm Antonio, I work here at Ladder. Today we're going to have 3 talks. Let's try and make them like every talk, maybe 30 minutes with questions already, and then we'll have like a 10 to 15 minute break between each talk. So Nikki's going to get us started first, then we'll have Huey, who works here, talk about GraphQL, and Daniel, who's visiting from Israel, as our 3rd speaker. The obligatory announcement is, as every tech company in Silicon Valley, we are hiring. So if you're interested in working with us, please come talk to me or Jack, who's right there. So yeah, let's get started.
Woo! Are there water bottles right there?
Yeah.
There's also water bottles right here. So.
And sunscreen.
And sunscreen. So help yourself.
All right, everyone. I'm Nick. I work at Expo, and today I'm going to be talking about using ClojureScript to live code mobile graphics. And so, since I work at Expo, I'm a little biased here, but I'm going to be using Expo as the way to do React Native on mobile. And React Native is a way to use React as your paradigm to do user interfaces on a mobile phone and have like native displays show up, right? All of that will make sense soon. But what Expo is in that whole picture is, and I'm going to be using boot to compile the ClojureScript for it to run on Expo. So there's like this whole mess of a stack going on, but it'll make sense. What Expo is it's a way easier way to do React Native stuff. Usually you need to run React Native through Xcode or through Android Studio or something, and you need to understand a little bit about Objective-C and Java just in case you want to patch in a native module that you want to use. So for example, by default, React Native has certain view components, like it's got like buttons or something, and it's got the ability to display images like GIFs and stuff like that. But if you wanted to display videos, for example, you can't do that out of the box, and you could hack it in with like a web view or something, but you would have to patch in some native code that you get from GitHub, right? And what we do is we provide a bunch of that out of the box so you don't have to think about it, and we make it so you don't have to compile the native code yourself. Like, a lot of it is way easier. In fact, one of the things we have is you can just open a web browser and start coding JavaScript in this online web editor that we have and scan a QR code from our development test app, and you can just run that native application without compiling on Xcode. So it's just like that whole process takes 30 seconds from not having touched an Expo ever. So you can ask me more about that because there's a lot of other stuff to talk about. But just to give you a sneak peek into what's possible with Boot Expo, you can do like reloading of saved files without restarts, and REPL stuff, which is the main 2 components of a good, I think, Clojure dev setup. But with a native, with an application that shows native UI on a phone. This is the simulator, but it also works like with the phone, which I'm going to show you. And there's not many steps involved there. It's just like you get it, npm instart and exp start, and you want to do a boot dev like simultaneously on the side if you want to like have a REPL running. So just to give you an idea of what the dev setup is like, the build.boot is basically the same as for a web ClojureScript application. So if you were to follow some good online boot ClojureScript tutorial, you would get the first task over there, which is analogous to a project.clj from Lanigan, but for boot instead. And this is saying I want a REPL and live reloading. And the one for Expo is basically the same, except we're being explicit about telling the reloader and the REPL thing to use your computer's hostname or IP address on the LAN, so that your phone, which is not actually the same device as your computer, so it can't use localhost, right? For the REPL, can actually connect to it over the LAN, right? So that way you get the REPL working. And oops, I skipped something there. Yeah, the other thing that was required, this is a bit hacky, but was that the Google Clojure library relies on the document object model to run JavaScript scripts, so it actually creates DOM elements like in the JS environment that you're in, right? And it tries to do that, but it doesn't successfully do that in React Native because it's a pristine JS environment that doesn't have document and stuff in it. So what I did was I wrote my own like asynchronous network JS loader, and I make it hot patch Google's JS loader when it loads Google's JS loader. So first it loads Google's base code, and then the next time when you're going to use Google's JS loader, it actually like changes the code of that to do its thing, right? Or yeah, and it just like hot patches that because you can do that. So that plus a few more things actually. The other thing is that the way React Native works, it needs to statically know the list of modules that you're going to require. And after that, you can just do the usual ClojureScript bootstrap process where you load the base Google library, and then you load cljs_deps.js, which sets up the dependency graph for the basic Google.require libraries that you're going to require, and then you load the main JavaScript. There's a little bit of a thing here where the normal boot CLJS Clojure compiler actually like generates a new namespace each time for the entry point using Jensen, so we don't know what the name of the namespace is going to be, so I have to like regex it out of the thing we loaded. Anyway, so there's a lot of stuff here, but the point is like you get what we showed you in the first screen, right, which is like the REPL. So that's part A for live coding mobile phone graphics, is live coding anything on mobile, right? But particularly we want to live code graphics, right? So how do we get graphics on React Native is the next question. As it turns out, this boot stuff I was doing recently, but what I was doing before was I was trying to get OpenGL bindings into a React Native space so that you can do OpenGL in React Native, but not through WebGL because you want to run the JavaScript in the same JS context as the rest of your code. So to again give you a sneak peek, this is the kind of stuff you can end up doing. Like these are like 3 of them are examples, but a bunch of them are actually games made by random people that use Expo. The one on the top right is interesting because there is a real-time camera stream in it from your phone's selfie camera, right? And you can probably do that with WebRTC now, like in the web, but the point is that we own the runtime, like we own the JavaScript runtime, so we can put whatever we want in there, right? So what I did there was I did the iOS camera stream and then put that as a OpenGL texture, and there's a native JavaScript call that just says, hey, can we use that texture instead of this static one, right? And so that works. And then in the bottom left, you can actually see that this is what is really interesting, is you can actually have interactions between native controls and OpenGL rendered controls, right? So the finger position there is coming from a React Native pattern responder, but the drawing is from a GL view, right? So you're able to actually use all of the good stuff in one place, right? And the top middle is a Minecraft game, and the controls for it are actually touchable iOS actual Apple like made buttons, right? Because it's rendering those over the GL view, and all of them are not in a browser. Like there's no browser involved, right? How the OpenGL stuff works is pretty interesting. So basically, this is the setup for sending data into OpenGL, right? You set up a bunch of buffer objects, and then you write a shader, and then you pipe the buffer through a shader, and then it renders all of that in real time. So all of this sounds really weird because it actually is pretty weird, like as a drawing paradigm. But the reason it's so weird is because I think they started with the GPU being something that you just give it vertices and it's like, okay, I'll show them here on screen. But then they started making it more and more programmable, right? And then when you get to this level of programmability, like it's all super abstract. Like nothing means anything actually because it depends on what you said it would mean in your shader, right? So that's why they're just called attributes rather than position or something. And what I ended up doing was actually binding the JavaScript directly to the C call because there is a spec already for OpenGL in JavaScript called WebGL, right? So if we just mirror that spec, then libraries that think they're running in the browser would just run in this new context even though it's not a browser, right? So that's what I did, and that's how those games work because those games use a library called 3JS, which is a library that is supposed to work in the browser, but we just changed the rug out from underneath, and like it didn't know that happened, and so it thinks it's like still in a browser, but it's not, and it renders 3D in Expo. So the whole crazy tower of abstraction actually works out
So does that mean you can just kind of take any WebGL game and it should run in this?
Yeah, there's like a few things that are tricky. So all of the WebGL calls actually work. I actually, so Kronos, which is the company, or I'm not sure if it's a company, but they make the WebGL spec, right? They have official integration tests to test to run on a browser to see if it's WebGL compatible, and most of them run on this, right? So that was a good way to see if the spec works. But the problem is a lot of those agents actually rely on document too, like to load images and stuff like that. They use the DOM to do that, right? So I had to hook into a few functions in 3JS that rely on that, and then make it do not DOM stuff. And the end result of that is you can use 3JS. So if you're curious, here's how the actual binding works. The bottom thing is C++, right? And the JS directly calls into that. It doesn't use the asynchronous React Native bridge because although that's nice in theory, in practice for when you're doing OpenGL and you're doing like thousands of calls in 60 FPS, like you don't want to go over the React Native bridge. Like instead, we just bind directly C functions using JavaScript core, which is the interpreter that React Native is using underneath. This is some C++ 11 stuff, like where we just, that's a partial function, right? So we're just, bind is like partial in Clojure, right? And we're just adding that as a feature to call later. So it's not calling all the OpenGL stuff in the JS thread, it's just enqueuing everything and it's gonna call later in the background at 60 FPS. So one of the neat things about that is you could actually encode a Clojure of not JS code, but it compiles it into something like this and it runs that at 60 FPS. So you could have 60 FPS animation running while your JS thread blocks, right, in OpenGL, which would be cool. But that's unimplemented at the moment. It's possible in theory. Anyways, so I said a lot of stuff, but the title of the talk was let's do graphics with ClojureScript, right? So I showed you live coding with ClojureScript, and then I showed you graphics with JavaScript, and then we know that ClojureScript to JavaScript is like a thing, that's the point, right? So if we put that in the middle, we'd probably get the whole composition of all that, right? So, and it's gonna be live. So I'm gonna try to do it right now. But what I have here is the boot Expo setup, and that on the right is a screen mirror of my phone. And so I'm just gonna load this application, which might take a second to connect to the REPL usually. And to come back here, just to highlight what I have here. So usually you would use something like Reagent or OhmNext or something to wrap React for it to be used from ClojureScript. But I actually decided to just use createElement directly and not do that. Just because like I'm still actually like learning stuff about ClojureScript, and I don't like want to do Reagent at the same time. And because I'm not sure if React Native views would break under it and stuff, so I'll figure it out later. Anyways, but down here, what we're gonna do is we're gonna REPL this in and hope it sees that. Let's see. So, oh, that's right. I need to actually connect to the REPL. So the REPL is from nREPL, and if you guys have used Cider before, you can just connect to an nREPL REPL from Cider and do like start REPL, right? And that should hopefully so I'm going to reload everything. But let's hope that it works the next time around. But while that's happening, let me give you a walkthrough of the code that we're about to run. So here, have people used 3JS before?
Could you make it a little bit?
Oh yeah, sure. Let me do that. And also I'll have to resize this. So. Yeah, that's nice. Okay. And what we'll do is we'll quit that REPL because it seems like it's hung. And we'll restart this project here. So all of that GUI that you just saw is Expo's stuff that runs your application, right? And over here, I'm just gonna pray that it works this time around. If it doesn't work, we'll just like talk about what I would have done. So yeah, here. So I'm gonna do this and open the REPL in over here and run start REPL, which starts the Weasel ClojureScript REPL. It's this huge stack of things that could break, you know. So, but anyways, it looks like it didn't this time, and we're gonna like not touch it too much. So yeah, all right. So here we go. The first thing we'll do is we'll swap in a view that just says "Welcome to the future." It seems like I'm having trouble like actually evaluating ClojureScript out of this buffer, which I'm not sure why. Let's see, +1, 2, does that work? Yeah, that works. Okay, cool. All right. We'll go with the actual OpenGL demo then and skip that. Okay, so let's see. Yeah, this over here is an OpenGL view that renders blue. Okay, that worked. Great. I'm like.
Ooh.
Okay, cool. So just to explain what happened here, this is how in OpenGL you clear the screen blue, right? You set the clear color and you set which bits of the, like using bits, you say which part of the output buffer you want to clear to, and then you push that frame off. So it's a very low-level API, and you usually don't want to do this directly, but if you want to, you can. So that's great.
Is that are those GL calls or 3JS calls?
Oh, these are actual GL calls that we're making right now, just to show you that like that's how you would do it, right? And the next thing that we're gonna do is we will require the 3 JS libraries and Expo 3, which is like it makes the renderer compatible with Expo's GLView. And what I do, which is interesting in Start GLView, is I actually like, this is sort of weird, but I have a full screen view, and then I add the GLView as a child of that in an array, but then like gensim the key every time so that it like updates, it like overwrites it each time, and then like it always forces an update so that you'll have a new GLView, and we can talk about that later. But over here, I'm just gonna start a 3JS render, and you'll see some warnings because 3JS is expecting certain GL extensions, but it actually doesn't. In practice, it turns out it doesn't care about that, so we're just gonna dismiss all of it, and then we'll go here and actually create a scene. So over here, I'm creating a perspective camera, and can you guys see actually, or is it still too small?
You mean the code or?
Yeah, the code.
Yeah, it's okay.
That's fine.
Cool. And I'll create the scene and start a rendering loop. So, moment of truth. There we go. Yes. So now you can start messing around with that cube like in real time, which is the fun part. So we can just set the cube's rotation to 72, which is a number I just made up. I don't know what that will look like. Okay. And this add loop thing was previously defined, and what that is it's this thing where I just have like an atom, which is a map, and then I keep swapping, like I swap in a new function that you added a certain key, and you can remove it from there, and then we're just gonna keep running all of those functions every frame, right? So that way you can add and remove loops every frame, and we'll just add. We added a loop called 3rendering for the 3JS renderer, and we'll add one for the cube rotation, and like you'll see it rotate now, right? And we can go there and change the speed of that to just faster, right? And it'll look faster. And we can also do other stuff, you know, I mean, at this point you can do everything. So we can just change the color to whatever this is. And yeah, so now you're live coding, you know, like mobile graphics that interacts with native views, right? And thanks. So yeah, this was a basic demo that I could fit into this time and into whatever time I spent preparing the demo. But you could now start adding views over it that interact with touch. So yeah, I'm gonna go back to the presentation and just ideas for the future. Just to show you guys some. Also, Antonio, like how much time do I have left?
Oh, you have like 10 minutes.
Okay, cool, awesome. Yeah, so just to show you guys ideas for where I'm like hoping to head with all of this. one of the things I experimented with in the past is a live coded game engine where it's in C, the engine itself, but the scripting layer over it is in Lua, right? And there was a lot more that I had to do, all of which is basically already done in ClojureScript, right? But like you can edit the properties of things visually, and you can select and move things around visually and all of that, which is a way more tangible and quote-unquote empathizable mode of interaction for people who are new to programming, right? That was one of the hopes, and the other hope was that you'll see the results of property edits that are in language space in real time, while you also see the edits of properties that are in like physical space in real time, right? So you're selecting things physically and moving them around, but you're also changing what things mean by semantic mappings to language, like numbers, right? Which is what programming, quote unquote, is, right? So you go here and you can change what the animation strip is for walking left. And once we add that, we can add that animation strip, and then in that top field, I change that to the left walk animation, right? And then it changes it to the left walk in real time, right? And you can also write code for this thing in real time and eval it, and then now you're making like a player character to move around. And this is in Lua, not ClojureScript, but we just saw how you can do this sort of thing in ClojureScript, and like you have the framework in place to achieve this eventually, right? And yeah, so you can change the speed of things and move them around. And just to give you a glimpse of how that could look potentially in ClojureScript is one idea that I've been messing around with, is one of the paradigms that I really liked that I found for data organization is the EAVT stuff that Datomic does, right, for example. And the reason that I like it is that usually when you store objects, either you store everything about the object in one place, which is things like object-oriented programming or game engines like Unity, or you blow it up and then you store them in separate tables like relational databases, right? But over here, this does the blowing up to the level of each attribute, right? So every row is just saying that some object has some attribute at some time, right? And all you're asserting is the minimal you know at that time, which is, hey, this attribute is this value. Like you don't have to say things more than what you know, right? And so this is now, what this is me just trying to describe objects in that phone eval space through DataScript, which is actually a Datomic, which is a thing that looks like Datomic and runs in the browser. And there's a lot of things about it that are different from Datomic, but still, right? And what we could do is, if the thing on the right, if instead of just something that shows stuff, you added callbacks that then trickle upwards saying how to change the thing, then now you have a live data editing interface. And then the other piece of the puzzle is having a visual editor for arbitrary closure immutable data types like maps and vectors and all that. And once you have that in there, if you put code in there, then you can also edit code visually. And then you can start getting to the fun place of making your application from itself, right? But yeah, so that's the hope. And this is just like random ideas that I sort of said already, like visual editors for code, and the idea of like having a distributed situation for the application state where you own your own objects and someone else owns their objects and they just send it to you or something. You're now in this playground of coding, right? So yeah, that's something I have to explore. But yeah, so those are the ideas, and this is the end of the talk. So.